So this is work example problem 7.1 on page 273. I think this is a pretty straightforward problem. If you actually look at the reading a little bit, it should make sense. You know, the general gist of the whole situation is that if I have an electron at an energy level and it drops to some other energy level, giving off a photon of light, the energy of that photon can be, or the frequency or wavelength of that photon is going to relate to the amount of energy that electron lost through the equation E equals hf. So you can therefore calculate the frequency of the photon of light. If you're asking for the wavelength, you just use there's another equation in your data booklet which is derived from this equation, that the speed of light or speed of a wave is equal to wavelength times frequency. So you can combine those two equations and end up with an equation that says E equals hc over lambda. I believe that equation is in your data booklet as well. So all these are pretty straightforward in terms of solving for wavelength or whatever. The critical thing to remember when you're doing these, however, is that usually you'll be giving the energy of the orbitals will be given in a unit called electron volts. And when you're using Planck's constant in an equation, it's imperative that the energy be converted to joules and not electron volts. So you'll have to figure out the energy difference between the two orbitals and then convert that to joules. And that conversion factor is not given directly in the data booklet, but if you remember the charge of the electron, which is given in the data booklet, 1.6 times 10 to the negative 19th, that's how many joules there are in 1 electron volt. So you can do that conversion factor and work it out. All right, good luck. Try it out. Let me know.